So this is the Pitot static tube. So the specific gravity of the manometer fluid shown in figure 4 is 1.07. So this is the manometer fluid. So the SG here is 1.07. Determine the volume flow rate Q if the flow is inviscid and incompressible and the flowing fluid is water. So this is water. So the idea of inviscid here means, so inviscid means it's related with the viscosity. So inviscid means the effect of viscosity is actually not give us so much problem. So we could ignore the viscosity effect, and it is incompressible means the density is constant. So there are no changes of density in this problem. And the fluid is water here, so we have this one. So and then here, please make sure that you really understand to draw the level of this manometer. So which one need to be higher? Okay, so the idea is very simple. Okay, let's say we know that Bernoulli equation as what you know previously, when the velocity increase, so the pressure will decrease. So the fluid flow from here, and then at this point it will flow at certain velocity. So and then when it go through this hollow tube, so it will flow downside here, and then when it reach this manometer fluid, so it start to stop, and then it will fill this hollow tube, and then it will become a stagnant here. So means that the velocity here, so here is the stagnation point. Okay, we have a stagnation point. So and then the velocity is equal to 0. So means that here we have velocity, here the velocity is 0. So at velocity, so for sure it has pressure. However, for the velocity 0 here, the pressure is higher. So mean because the pressure is higher, it's capable to push the liquid here deeper. So it could push the liquid here until the level difference is 20 millimeter. So you could understand, so means that the pressure here is less compared to the pressure here, because this fluid could move upward because the pressure here is less compared to the right one, compared to the right column here. So please understand the idea of Bernoulli equation, and I hope you could estimate which one is higher, which column is higher in Pitot static tube. Because sometimes we give you this question, but we do not give the diagram like this one. We just say that the manometer level or the manometer difference is 20 millimeter. So the manometer difference is this level. So mean level from this surface to this surface. Okay, and then how to solve this one? So okay, boleh nampak ke yang ini? Tulisan tangan saya boleh nampak ke? Boleh baca Okay, kalau boleh baca. Boleh. Okay, so kalau boleh kita kata, so this is the answer for that question. So for example, we have a pipe here. So and then we have a Pitot static tube. So we have this tube. So one is actually measuring what happened inside the pipe, and another one here is attached on the surface of the pipe only. So and then this is the level of manometer liquid here. Okay, so and then normally we will take this point. So we take one point on the at here and another point at the stagnation point. So this is point number 1 and this is point number 2. But before that, please determine or please check the streamline. So usually we assume that we have a molecule flow pass through point number 1 and pass through point number 2, and then it will continue the flow like this one. So means that because all the molecule point number 1 and point number 2 is on the same streamline, it means that it is okay for us to use Bernoulli equation to compare the energy between point number 1 and point number 2. So next, we need to list down all the parameter for point number 1 and point number 2. So for point number 1, we could say that the pressure here so is unknown because we don't know the rho GH and so on. So means it's not equal to 0. So it is unknown and we need to measure it. So and then the velocity at number 1 is also unknown, but for sure the fluid is moving at certain velocity at point number 1, and then the velocity z here can be determined. So it is depend on the datum. So for example, I take the datum here. So as I said previously, you could take any level become a datum. So means that if I take this is the datum, so mean the height of Z1 here is 80 millimeters. So we have a 20 here. So let's say I add with my own from the question, it is 10 millimeter here, and we have okay, let's say we have a 50 here. So the diameter is, I'm not so sure, so we check the, okay, so the diameter is 0.09 and the height here is 0.05. So we have, this is the 10 millimeters, so this is 20. So means that, so this is the correct dimension here. So the total of distance from the datum to point number 1 is 80 millimeters. So and then for point number 2, so we also don't know the value of pressure at point number 2. The velocity is equal to 0. So this is very sure because at point number 2 here, it is a stagnation point. So velocity is equal to 0. And the datum for Z2 is also 80 millimeters. So and then we could calculate. So according to this list, to this parameter, so we need to determine what is the value of P1 and what is the value of P2. So we learn how to calculate the pressure from the previous chapter. So please make sure that you know how to measure pressure or to start your calculation of pressure. So it starts from the idea of Pascal paradox line. So we draw a line here. So this is the best line for Pascal paradox. So and then let's say we have this is point A and this is point B. So and then we could say from this one, from the Pascal paradox lines, PA is equal to PB. So and then we could calculate the pressure. So mean the pressure at A here, as mentioned here. So it is equal the rho G 0.02 means the pressure because of this height. And then we add with pressure because of water 0. From here until this point. So mean it will become rho G 0.06 because the distance is 10 mm and 50 mm here. And then we add with the pressure that acts on point 1. So we write plus P1 here. So and then if we substitute all the value, so we could get that P1 here is equal to PA minus 798.534. So the unit is Pascal because we are calculated the pressure. So and then we could calculate the pressure for point B. So point B here is the pressure at this point. So it is because of rho GH of this 20, this 10, and also the 50 millimeters. So the total is 80. So we could calculate the pressure of PB is equal to rho of water of 0.08 meter plus pressure at point 2. So P2 is equal to this value. P2 is equal to PB minus 784.8 Pascal. So and then we could substitute the in our Bernoulli equation. So this is our Bernoulli equation, P1 and P. We have P, V, and Z for 1, P, V, and Z for 2. So please remember P over rho G, V square over 2G plus Z. So we substitute everything. So and then we could get the P2 minus P1 is equal rho G times V1 square over 2G. So P2 over P1 can be written like this one. So it is because we already get the value of P1 here, and we get a value of P2 here. So and then we substitute into this equation. Okay, we substitute into this equation. So and then according to the Pascal paradox line, pressure at A is equal to pressure at B. So and then we could neglect, or we could cancel out the value of PA minus PB, PB minus PA, and then we could the only unknown parameter is V1. So according to this calculation, so the velocity at V1 is 0.166 meter per second. So and then we could calculate the flow rate, the volume flow rate. So the volume flow rate here is Q equal A times B. So we know that we have a pipe here. So we have a Pitot static tube like this one. So we take the diameter of this one, it is 0.09 meter. So we could calculate the cross-sectional area, and then we know that the velocity is 0.166 meter. So we could get the volume flow rate is 1.06 times 10 minus 3 meter cube per second. So this is the flow rate that flow through the pipe. So means that after this you could remove your Pitot tube here. So and then you know that the flow inside this pipe is 1.06 times 10 to the power of negative 3 meter cube per second. So that's why if you see in pipeline, okay, sometimes people only replace certain area of pipe with a Pitot tube to measure the pressure and velocity, because in real application, flow rate is very important, because we want to know whether there is the force. Later on we learn about force. The force that occur on that pipe is enough, it can be sustained by the pipe itself or not. If not, there will be a leakage and a burst inside a pipe later on.